All right, so properties of logarithms, there are 3 total, which you just have to sort of remember, okay? So here, this is the first property, is log base b, m times n, right? So log base b, m times n, is equal to log base b of m plus log base b of n, okay? So if you want to know where this came from, right? What is a logarithm? A what? A logarithm is a what? What question? It's an exponent. That's what I was getting at. A logarithm is a what? Exponent. An exponent. So if a logarithm is an exponent, right? So now if I had, let's say, x squared times x cubed, what do I do to those exponents? You add them, right? This is going to be x to the power of 2 plus 3. So if we're taking a logarithm, if all we're doing is adding exponents, then the exponent, take a look here in the blue, the exponent of something multiplied, right, is what? It's the sum of those exponents. Do you see where the formula comes from? So when we're dealing with exponents, if we're multiplying powers, we add the exponent. If we're multiplying powers, we add the exponent. Think of it that way, and there is less of a chance for you to, to get confused. So if it doesn't seem to fit in, memorize it. This is like one of the only things I'm okay with you just memorizing. Okay? Yeah.
So it's going to be like log 2b plus mn.
Yeah, log b plus log n. So now this one, it says to use the product property to expand each logarithm, right? We're going to expand the logarithm. So here we have log of something that's being multiplied. So what happens is each guy gets its own log, right? And then we add them. And that's it. That's all. Okay? Now, a few things to be careful about here. Okay? Look at inside the log, how many elements are there? You have a 3, you have a 5. You have 2 elements in there. So when all is said and done, that's how many logarithms should show up in your answer. So a 3 and a 5, that's 2. You have a log and a log, that's 2 logs. Okay? Yeah.
I'm kind of confused about how the property or the product property goes with this.
Well, what was the saying? Is inside the log, you have 2 things that are being multiplied, right? What do? You give each one a log, and you add them. That's all. Yeah.
I didn't realize that.
Yeah. That's the answer. That's it. This is it. This is the answer. Okay, so let's do this next one then. How many elements inside? 2. So we're going to have log base 2 of 5 plus log base 2 of 7, right? You've got the log. You've got the base 2 that carries along. Okay? That's it. This is it. You can't simplify this anymore. All right, here, how many elements are inside? 2. So it's going to be ln of 4 plus ln of x. Now, if any one of these is something that could be simplified further, then you should. But if it doesn't simplify any further, then you just leave it. Okay? So these, you're good. You just leave it as ln of 4 plus ln of x. That's it. You don't need decimals. You don't need anything. So even this you could do without a calculator, right? Yeah. All right. So take a look here. How many elements are inside? 1, 2, 3. So what is it going to be? Log base 2 of what? 5. Right? And then? Plus log base 2 of a plus? Right. That's all. 3 logs. Okay? All right, so go ahead and do the next one then. So log base 4 of 3, log base 4 of x, log base 4 of y. All right, that's all. Now, what about the next one? What would you assume we're going to do first? What is it? ln of what? 5. ln of 5, and then what?
ln of 3x.
Right, plus ln of root x, right? So let's take a look here. I have a 5 and I have a root x. That's two things. But now, for the first time, this has something more that we have to do. Right, the root. ln of 5 is good. But this one, it's ln of x to the what?
-1.
Root x becomes x to the half. Okay? We did know this because of the previous section, right? Look on page 16. Anytime you've got a root, it translates to an exponent of 1/2. All right? Root 3, 3 to the half. Root x, x to the half. Root table, table to the 1/2. Okay? All right. Now, this is not the full story just yet. We're just going to leave it like this. There is like a, to be continued here. We're going to come back to it. Okay? Now, how do you express a logarithm in terms of logarithms of two constants? So often, you'll have a question like this. Express log of 12 in terms of log 3 and log 4. Okay. How the heck do you do this? So first of all, the numbers they give you, right? What are they? You have a 12 and 3 and 4. They multiply together. So they're always going to be like some factor of the first number, the bigger number, the 12. Okay? Now, what we're going to do is first break down the constant of the original logarithm into smaller numbers which will multiply to the original. So we already said that 12 is going to be 3 times 4, right? Okay. So we're going to break it down. I mean, yeah, I could do 2 and 6 too, but that doesn't have anything to do with 3 and 4. So I need to break down the 12 in terms of 3 and 4. So now, log of 12 is log of 3 times 4, which then will be, now we have to use the properties, so it's going to be log of 3 plus log of 4. Okay, so break down the number, use properties. Break down the number, use properties. All right, we can do this. All right, so let's do log of 6 then. We have to write it in terms of log base 2 and log base 3. I'll give you half a minute to do this one, and we'll come back to the record. It does not matter which number you put first because multiplication and addition are commutative. This much work is a good amount of work to justify your answer and to get partial credit if there needs to be partial credit. Okay? Yeah.
I wrote it backwards.
It's totally fun. That was her question. It's totally
not the 2 and the 3. I'm saying I did your second step first and
the
second step was the answer. What's
no,
your answer?
This is the answer. It needs to be expanded. Right? Okay, so let's do the next one. It'll be what? Final answer.
Log 5 plus log 3.
Right. Okay. Awesome. All right, now we did the products. All right, so remember we started with, we said if you had x2 times x cubed, you add the exponents. Well, what if you have x to the 7 over x to the 3? What do you do then? You subtract the exponents, right? 7 minus 3. So when you have, right, so here's the quotient property. When you have a logarithm of a quotient, okay, logarithm, something divided by something else, you have to split them up and subtract. Okay? So a logarithm is a what? An exponent. A logarithm is an exponent. So if it's the logarithm of one thing divided by something else, you have to subtract the power. So you subtract them. Okay? Okay. All right, so let's do this one. 20 seconds. Do that first one. Any ideas?
Yeah.
What do we think? ln of 3 minus ln of x, right? So we're using the quotient property. So far, this is the second property we've learned. Now, what about the next one? Log base 3, right? Let me do an intermediate step. Oops, minus log base 3 of y. And then you can't leave it like that because that'll just be half credit. X to the 1/2 minus log base 3 y. And this too, dot, 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 to be continued. Okay? Well, we're going to come back to it. Okay? We're going to come back to it. So, okay, so this is too boring now because you're either just multiplying or just dividing. Well, what if there is an expression that contains multiplication and division? Oh my gosh, what do you do, right? So if it contains both a product and a quotient, here it is. Each element that is in the numerator is added, so that each element in the denominator will be what? Subtracted. So take a look here. I have 2a over b. How many total elements are there in here? 3 elements. So take a look. The 2, right? That'll be a positive. The a, that'll be a positive. The b will be subtracted. So here's what we do. We start log base 3 with the first element in the numerator, 2. Now the a, it's going to be a plus minus log base 3 of b. Okay? That's all. Each item in the numerator will get a plus. Each item in the denominator will get its own individual minus. So I'll give you 40 seconds to do D and E. Go. What about the y? Right. Fabulous. Okay?
So even though it's been multiplied, you still...
Yes. Okay, common mistakes. There's a 3 here. Okay, now, a couple of things we need to do then. Take a look at this. Is there anything that we could simplify further?
Yeah.
This one. Which one? In D. Is there anything we could simplify further? Log 2, 5? Can't do much about that. Log 3, 3. Oh, no, wait. That's my mistake. Sorry. I jumped ahead of myself. All right, so we're good. All right, so let me show you some common mistakes. Common mistakes is a student will write log 2, 5 plus log 2 x minus log 2, 3y. This is probably, this probably makes up 95% of the mistakes I see. All right? This is, technically it should be no credit. It's half credit at best. Okay? All right. What about the other one? ln of 2 plus ln of r minus ln of t. Right? Did I do that correctly? Yes. Say yes. Yes. Okay. Now, here's a third and final property of logarithms. It's the power property. When you have log base b of m to the power of p, you're allowed to bring the p down and it becomes p log of m. Okay, what does all that mean, right? I'll tell you what all that means. Take a look at this one. You have log x to the power of 2. The 2 just comes down and it becomes 2 log x. That's all. Okay? So now, let's take a look at this next one. How many elements are inside the log here? You have an x squared and a y squared. That's 2, right? So you're going to end with 2 logarithms. Log base 3 of x squared plus log base 3 of y squared. And now you scan and you ask yourself, are there any exponents? There sure are. There is a 2. There is a 2. They each come down. 2 log base 3 of x plus 2 log base 3 of y. And we're done. Okay? That's all. Power property of logarithms. Before we're doing the quotient property, these are all called expanding. And then you just use the 3 properties. So what about the next one then? What's the first step? It's ln of x to the, yes, yeah. And then you bring the 1/2 down, 1/2 ln of x. So let's just pause here for a minute then and go up. Go up to our first to be continued, right? That's on page 19. What happens to f here then?
You have to 1/2 of the 1/2 down.
Right, so it'll be ln of 5 plus 1/2 ln of x. You see that? Now it's a final answer. Okay? And then what about b on the next page? Same thing. Fabulous. Okay? All right. Okay. This next one then. What do we think? 3?
Do you multiply the 3 and 2?
Yes, you're way ahead of me there. But you do. Are we okay with this step? I don't know why I'm yelling. I'm so excited. The 2 comes down, right? The 2 comes down. So now it's 2 times 3 log base 2 of a plus 3 log base 2 of b. So finally, it's 6 log base 2 of a plus 3 log base 2 of b. Now, if you wanted to skip that middle step, of course you can, right? Of course you could go from the first step to the last step, okay? In fact, I don't think I'll ever do that step again. Okay, now for some good ones. Ready? Okay. All right, so this is log base 2 of what?
32 1/2.
Okay, so this is log base 2 of 32 to the 1/2. All right, let's just get rid of the 1/2 first, right? So it'll be 1/2 log base 2 of 32. What about 32? Look at the base there, right? So take a look at this for a minute. Just this, right? A logarithm is an exponent. So if I see just the stuff in the green circle on a billboard, I'm thinking to myself, 2 to the power of what equals 32, right? And it's how much?
4,
One more?
5.
5, right? So then this is 1/2 times 5. 2 to the power of, well, let's see. 2 times 2,
Oh, 2 to the
4
power of 5 down 5
times 2,
Oh, that's
8, 16, 32. So 2 to the power of 5 is 32.
5 to the power of 2.
Right. 2 to the power of 5. That's actually a good thing to just know. Just, just because 2 to the power of 5 is 32. 32 is 5 2s. 2, 2, 2, 2, 2. Okay? So this is just 5 over 2 then. Okay? Now, I'm going to give you 3 minutes to do F and G. Go, 3 minutes. So just to summarize, right? We got a 1 here and an 8 there. Just to summarize, what we did today was called expanding logarithms. So on your test, on your quiz, on your homework, you're going to be asked expand the logarithms, and that's exactly what we did, right? So we have to expand the logarithm so that you have as many logarithms as there are elements in the original. Rewrite exponents as what? Exponents come down and they become, what's the word? Coefficients, right? And if an element is in the numerator, it's being added. If it's in the denominator, it's being subtracted, right? So the homework that goes with this is assignment 6, not 5. I apologize. So just cross that out and say it's assignment 6. You want to do that because it's a handout, and the handout is labeled as assignment 6, okay? And then next time, we're going to do everything backwards. Okay? All right.
Wait, what was highlighted?
Here. Okay, so we'll stop here.